Very good afternoon to all of you. So this is our second video regarding the pericyclic reaction. So yesterday we discussed about the pericyclic reaction and in particularly the electrocyclic reaction. So today we will solve some previous year question. These all are the previous year question. And so before we going further, firstly we recap whatever we study yesterday, and then we'll solve this question. Okay. So yesterday we will discuss about the electrocyclic reaction. Okay. So you just uh, memorize the one table. Okay. Heating condition and photochemical condition, and the two system, 4n pi electron system and 4n plus 2 pi electron system. You just memorize these things. Okay. So in the 4 pi electron system, when we apply the heat, then it is con-rotatory movement of the p orbital. Okay. And we already discussed previously, in the con-rotation the stereochemistry will change. Stereochemistry is not remain same, but stereochemistry change. Okay, stereochemistry change in the con-rotatory motion. Okay, and in the 4 pi system, when we apply the photochemical condition, then reaction occurs through this rotatory motion, and in this rotatory motion, no change in stereochemistry of the product, no change in stereochemistry. Okay, we'll discuss example related to the stereochemistry. Okay, and in the 4n plus 2 pi electron system, opposite is whatever opposite conditions are true for the 4n plus 2 pi electron system. Means in the heating condition, this rotatory motion of the p orbital. Okay, so no change in the stereochemistry. No change in stereochemistry. We already discussed in the previous lecture. Okay, so and in the photochemical condition, the con-rotatory motion will happen and change in stereochemistry. Always in the con-rotation, whether it is photochemical or heating condition, in the con-rotation stereochemistry is always change. Okay, from the starting material to product. Okay, so stereochemistry will change in stereochemistry. Right. Okay, so now we'll solve some previous year questions. Okay, so just a minute, I just see whether the video is filming or not. So video is filming. Okay, so today we'll discuss these 4 examples. Okay, and also we will discuss more example as well. Okay, so first of all we'll start with this example. Right. So in this reaction, we apply the heating condition. Okay, so what type of electrocyclic reaction happen, whether it is 4n pi electron system or 4n plus 2 pi electron system? How do we decide? This is very important. Okay, because you clearly see that, you can see that here the 1 2 3 4 5 6, so 6 pi electron. Okay, so there are 2 possibility for the electrocyclic reaction. Okay, 4 pi electron system, whether it is proceed through 4 pi system or whether it is proceed through 6 pi system. We already know that the 6 pi in this case, okay, if there are 2 possibility, one for the 4n pi and one for the 6 pi electron, then reaction always occurs through 6 pi electron system, because 6 pi electron system is a thermodynamically 6 pi electron system is occurs through the 6 pi six member transition state. Okay, so it is thermodynamically more favorable. That's why this reaction occurs through the 6 pi electron system. Okay, so here you clearly see that here the stereochemistry is very important. Okay, so see in the 6 pi electron system, when we apply the heating condition, then this reaction occurs through the this rotatory motion, and this rotatory motion stereochemistry remain same, no change in the stereochemistry. So these two carbons are preserved. Okay, no change in this stereochemistry, and also no change in the stereochemistry of this carbon as well. Okay, so I number this carbon 1 2 3 4 5 and 6. Okay, so you can clearly see that both these two double bonds are cis double bond. This is also cis double bond and this is also cis double bond. Okay, so one thing you should keep in your mind, if two cis double bonds are present in the compound, then the overall compound is cis. If one cis double bond and one trans double bond present, then overall compound is trans. When two trans double bond are present, then overall compound is cis. Okay, so you should keep in your mind this thing, keep in your mind. Okay, while you solving this type of question. Okay, so here the bond go like this. Okay, 6 pi electrocyclic reaction occurs to the 6 member transition state, and this is the these two double bonds are cis in nature. Okay, so these two hydrogens are facing in the same direction. Okay, so here the six member ring will form. 6 member ring is formed. So here the 6 member ring. Okay, and here 1 2 3 and 4, the 4 member ring. 6 member ring fused with the 4 member ring. Okay, and this stereochemistry, no change in this stereochemistry. This stereochemistry remains same. Okay, so here the methyl and here the methyl. What about these two hydrogens? Whether these two hydrogens are cis in nature or trans in nature? So we already talked about this. When two double bonds are cis in nature, then compound is overall cis. So these two double bonds, these two hydrogens are also cis in nature. Okay, so these two hydrogens are facing in the same direction. Okay, and here one double bond and here one double bond. So this compound is cis compound. Right? I hope you understand this question. So wait for 1 minute. I just see whether video is filming or not. So video is still filming. So we can solve further example. Okay. Okay. Now we'll discuss about this example. So how to solve this question? Okay. First of all, previously also we discussed about the types of electrocyclic reactions. So there are two types of electrocyclic reactions: ring opening electrocyclic reaction and the ring closing electrocyclic reaction. So this is the ring closing electrocyclic reaction. Okay. So now in the second example, this is a 4 member ring. Okay, it is very strange ring. So here the ring opening electrocyclic reaction occurs. Okay, in the heating condition. So this is 4 pi electron system. This is 4 pi electron system. So in the heating condition, 4 pi electron system occurs through the on rotation. And in the on rotation, stereochemistry is changed. Okay. So here this bond goes like this and this bond goes like this. Okay. So here what will happen? Okay, here double bonds are present in this. The ring is open, and here methyl, and here double bond. Just a minute. Cyclobutadiene is formed. Okay, not cyclobutadiene plus, but butadiene is formed. Or like this. Okay. So this is the product of our reaction. Okay, whether the product out of, there are two possible products. Okay, right. I hope you understand this concept. Okay, now we'll discuss about the third question. Before we going further, I just see the way video is filming. Okay, 10 minutes are gone. Okay, so in the third equation, chemical equation, here also the electrocyclic reaction occurs. Okay, so here the ring opening is happens. Okay, in the heating condition, this is 4n pi electron system, and in the 4n pi electron system, in the heating condition, it will occur through the con rotation. Con rotation. Okay, right. So similar reaction goes occur in this case as well. Okay, so this bond goes like this and this bond goes like this. So ring opening take place, and here the butadiene is formed. Okay, here the butadiene is formed. This is very important. Okay, because the double bond is present here, and here also second double bond, right? And third double bond is here. Okay, now reaction not stop at this point. Okay, the reaction further going. In the heating condition, you can clearly see that there are three double bonds present. Okay, so here the 6 pi electrocyclic ring closing reaction will occur. Okay, so here this bond goes like this, and this bond goes like this, and this bond goes like this. Okay, so 6-member ring will form. Okay, and here the product is to fuse 6-member rings. Okay, these double bonds are still remain its position, and one double bond here and one double bond here. So this product is formed in this reaction. I hope you understand this reaction. Okay, now we'll discuss about the fourth reaction. Fourth reaction very important. Okay, because this is asked in one of the previous year paper. Okay, so you can clearly see that here there are two types of possible system. First of all, here there are 4 double bonds. Okay, 4 double bond means there are 8 pi electron system. 8 pi electron system. Okay, so whether it is this reaction, either this reaction going through 4n pi electron system, or this reaction going through by 4n plus 2 pi electron system. Okay, so we discussed earlier, in this case always reaction occurs to the 6 pi electron system. Okay, so these 3 double bonds are undergoing electrocyclic reaction because 6-member ring is thermodynamically more favorable as compared to the 4-member ring. Okay, and here okay, just a minute. Here the reaction occurs to the 4n pi electron system. Okay, because the 8-member ring is sterically very flexible system. Okay, as compared to the 6-member ring. So this reaction occurs to the 4n pi electron system, and in heating condition we all know that the con rotatory motion. Okay, now you solve this equation very carefully, because here there are 2 hydrogens. Okay, so in con rotation always stereochemistry is changed, right? So here you can clearly see that the both the double bonds are cis in nature. Okay, so these hydrogens are also cis in nature, right? So now the electrocyclic ring closing reaction will occur, and how many rings will be formed? 1, 2, 3, 4, 5, 6, 7 and 8. 8-member ring is formed along with 1, 2, 3. 3-member ring is formed. Okay, even though this is very sterically very hindered ring, but here this reaction occurs to the 4 anti-electron system. Okay, so here 8-member ring and here the 3-member ring, right? And here hydrogen also present at the nitrogen. Now the stereochemistry is very important. Here the double bond between 3 and 4 and 5 carbon, okay, and here double bond between 6 and 7 carbon, and here double bond between 2 and 3 carbon. Stereochemistry is very important at the junction of 8-member ring and 3-member ring. So here the 6 double bonds are present, okay, and here these 2 hydrogens are cis in nature, but the stereochemistry is changed in the product, because in the bond rotation always stereochemistry is changed. Okay, so here the trans product is formed. Okay, so this 4 reaction. Okay, I hope you understood this 4 reaction. Now we'll discuss some more examples. Okay, so before we going, I just see that how many minutes are gone. Okay, so already 16 minutes are gone. So I hope you understood these questions. These all these questions are the previous year questions. Okay, so I upload another video today itself. Okay, after uploading this video. Okay, so that's it. Thank you.